Thanks for watching and welcome to the most important example of the wave equation called the Plucked string. In other words, suppose you start with a triangle, so imagine this being a triangle, and you let it go down, then what happens to that triangle? In other words, suppose we want to solve utt equals uxx with the initial condition u of x0 equals phi of x, where phi is a triangle. In other words, at 0 it has value 1, and then it goes down until at plus minus 1 it has value 0, and then it's just 0 after that. So more concretely, what is phi? So phi of x is 0 if x is less or equal to minus 1. It has intercept 1 and slope 1, so 1 plus x if x is between minus 1 and 0. It has intercept 1 and slope minus 1 between 0 and 1. So in other words, 1 minus x if x is between 0 and 1. And lastly, it's 0 if x is greater or equal to 1. So that is phi, which is really a piecewise defined function. I know you can write this with absolute values, but here it's more concrete. Now, what is the solution? Luckily, we do have D'Alembert's formula. So D'Alembert's formula tells you that u of xt is 1/2 phi of x minus t plus phi of x plus t, and plus the integral of the velocity, but here the velocity is 0. So that's all we have. And what we want to do, we want to analyze a couple of values of t until we get a nice movie of the solution. And so let's start. Well, for t equals 0, maybe obvious, but u of x0 is 1/2 phi of x minus 0 plus phi of x plus 0. And you can cancel that to get phi of x, which is hopefully not too surprising because phi is the initial condition. And in particular, at t equals 0, what the solution looks like is just this triangle. That's sort of what we start with. So minus 1, 1, and then this is 1 at 0. So it's u of x0. And more precisely, let's now look at what happens for t equals 1/2. So once again, just for concreteness, here's a formula of phi. And now let's see what happens as t is 1/2. So what we know is u of x 1/2 is 1/2 phi of x minus 1/2, and then plus phi of x plus 1/2. And again, here, what we'll do, we'll analyze several cases and then see what happens to u. So first of all, what if both x minus 1/2 and x plus 1/2 are in this region? So case 1, in other words, what if x is less than or equal, in this case, to minus 3/2? And then we will see what happens. This might be minus 3/2. Well, in this case, well, u of x 1/2 is 1/2 phi of x minus 1/2 plus phi of x plus 1/2. But in this case, for sure, x minus 1/2 is less than or equal to minus 1, and so is x plus 1/2. So both of them are in this region, and so we get 1/2 times 0 plus 0, and this is 0. So in other words, if x is less or equal to minus 3/2, u of x 1/2 is 0. All right, now, next scenario, what if x is between minus 3/2 and minus 1/2? So once again, case 2. So x is between minus 3/2 and minus 1/2. X and minus 1/2. Then once again, remember our solution formula. U of x 1/2 is 1/2 phi of x minus 1/2 plus phi of x plus 1/2. And here we have a big change. So first of all, this thing is still less than or equal to minus 1, but now x plus 1/2 is between minus 1 and 0. So it's in the interval minus 1, 0. So, in other words, x minus 1/2 is in this region, so we still get 0. But now, x plus 1/2 is in this region, so we get 1 plus x. So in this case, 1 plus x plus 1/2. And if you do this, so you have 3/2, which becomes 3/4, and then x over 2 is x over 2. So in other words, you start getting a little triangle here. Triangle, and then with what value? So at minus 1/2, this is minus 1/4 plus 3/4, so it's a triangle with height 1/2. And well, let's continue. So now let's figure out what happens between minus 1/2 and 1/2. And then let's see if we get something interesting. Case 3. So x is between minus 1/2 and 1/2. So in this case, u of x 1/2 is, once again, phi 1/2 phi of, I know so many 1/2s, but x minus 1/2 plus phi of x plus 1/2. And now you get something super interesting, because if x is between minus 0.5 and 0.5, x minus 1/2, that is in minus 1, 0. On the other hand, x plus 1/2 is in 0, 1. So x minus 1/2 is here, x plus 1/2 is here, and so we use both definitions of phi. So that becomes 1/2, and then 1 plus x minus 1/2, and then plus 1 minus x plus 1/2. And the cool thing is, so there are a couple of cancellations, the x cancels out, and then we have minus 1/2 minus 1/2, which cancels out with this 1, and so in the end we have 1/2. So in other words, here we have this little plateau. And of course, you may notice there is a symmetry, so I won't do the same thing again, but then what's nice is you can simply complete the picture. So case 4 would be x between 1/2 and 3/2. And you would see that the phi or the u goes down, and then if x is bigger than 3/2, things are again 0, and you end up getting u of x 1/2. Looks like this. And of course, similar to here, you can plug in other values of t, and you find the following nice movie of the solution. So kind of as a summary, what did we get? So at t equals 0, we found that u just looks like this triangle, as usual. So that's u of x 0. which is a triangle with spike 1, at t equals 1/2. You find that this triangle slowly becomes a plateau. So minus 3/2, minus 1/2, 1/2, and then 3/2. So in this case, it becomes a plateau with height 1/2. 1/2, so that's u of x 1/2. Now, on your homework, you will do the cases t equals 1 and t equals 2. So at t equals 1, what you get is that this plateau becomes two triangles. So minus 1, 1, and then 2, and then 2. So you get two triangles of a certain height. Your x1. And again, the height that you will determine. And then last but not least, let's say at t equals 2, you will see everything will split off. So if I'm not mistaken, again, correct me if I am, you get, I think, 0, 1, 2, 3, and then minus 1, minus 2, and then minus 3. And you end up getting something that just goes like this. So now two triangles. Or like that. So that would be u of x2. So you see kind of a cool movie of the solution. You start with this triangle that plateaus, that splits into two little triangles, and then both of which move to the right, which is very, very neat. And by the way, in the description, you can find a cool demo of this, really illustrating this. All right, I hope you like this little wave adventure. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.